So, following on from Alistair, so my name's Paul Kamphuis, General Manager with Polytan, Asia Pacific. So I've been in the industry for 12 years. I came in as a civil engineer, so my expertise is originally in the building the bits underneath and the design work, and I've learned a lot about hockey pitches and the synthetic surface technology as I've gone along. So I don't think we've got anybody here who was at the other sports facility masterclass we had this morning, which is good because otherwise you would see that some of the stuff that's in this presentation I've already done once today. So what I'm going to go through today, pretty quick overview of hockey facility construction, fairly basic level stuff, just company background briefly, product development cycle, a snapshot of the construction process, and I'll provide a real-world example with Rio 2016, which I've been asked to do as part of this masterclass. So just briefly, company background. So Polytan and our manufacturing company APT, we're based in Melbourne. We've got over 30 years experience in the synthetic sports surfacing industry. We're part of a global group called Sport Group with our parent company now based in Germany. 19 companies in 9 countries around the world, about 1,200 employees. In Australia, about 120 employees. The product we manufacture here is used on all fields we do in Australia, through New Zealand and throughout the Asia Pacific region. We've also manufactured the product here for the London, Beijing and Sydney Olympic Games and a whole range of other major international hockey tournaments as well. So when we talk about our company, we've got vertically integrated manufacturing. We make everything in the synthetic system. We extrude the yarn, we make the master batch, which makes up the yarn, which is the colour, the UV inhibitors, all of those kind of things. We tough the synthetic grass product, we make the coatings that go on the back of that hold the fibres in. We make the adhesives, we make the polyurethane binder that goes into the shock pad underlays. We've got in-house design capability for hockey and other sports, in-house project management for the construction of the facilities, and obviously what we do best is we specialise in the surfacing. Oh, wrong button. So Polygrass is our hockey trademark name. All of our hockey products fall under the Polygrass name. Polygrass surfaces have become synonymous with hockey at an Olympic Games level. Sydney 2000, Beijing 2008, London 2012, the Smurf Turf, Rio this year, and as Alistair mentioned, we've also reached an agreement with the FIH for Tokyo 2020. I personally have worked on the last 3 Olympic Games, inclusive of Rio, and yeah, we'll be in Tokyo later this year to start the process there. So project development cycle, what's involved from concept to facility. So we've developed this closed loop diagram, and we don't have a pointer here unfortunately, but which basically goes through and diagrammatically explains the process from concept, which is at the top there with the blue line, right through to development of the facility ready for use on the other side. So we've got 2 key sections in the outer loop there, what we call engineering and what we call development. So the engineering is the concept work and the site appraisal stages, it's getting the funding, it's all of those things, getting planning approval, getting to the point where you can actually do construction work on site. And then the development phase is the actual nuts and bolts construction work that we do to build the actual facility. Sitting inside that, the next loop in is project management. Clearly, right from the concept stage right through to the delivery of the end result, you need management of that project process. Inside of that, you need to then consider the performance standard that you're after, and you also need to consider the sustainability requirements for the project. And at the heart of that, the core of everything that we do is the research and development to make sure that the systems that we develop are suitable for the sport that we're dealing with, in this case hockey, and to suitable to the standard of play that's expected for that facility. So obviously what we tend to do is we focus a lot of our R&D on the elite end with hockey, and we look to then filter that back down through our other product systems that could be used at club level hockey and in other applications. So the planning process, obviously all hockey facilities start as an idea and a desire. Generally it's a case, traditional case here in Australia is that hockey will be played on natural grass and everyone will decide we don't want to play natural grass anymore, let's get together and let's try and build a synthetic pitch. And the idea starts from there, which is a great way to start, and then it has to go from there. But there can be a few hiccups along the way. Not everybody, hopefully none of the projects get violent, but certainly there can be a lot of setbacks which feel like a slap in the face, and about making sure that you've got a system in place to cope with all of that and make sure that you can continue that planning process forward. So project planning is essential, and there's a whole range of different things that are involved in that. You need to determine what the project aim is. Ultimately, in this particular case, we're talking about building a hockey facility, but there might be other aims that are connected with that. It could be we're building a hockey facility because we currently can't keep up with the amount of usage we've got on natural grass fields, or we're building a hockey facility because we want to grow hockey within this region, or we're building a multi-sport facility and we want hockey to be part of that multi-sport facility so that we can get access to for hockey within this particular location. It's not always purely and simply we want to build a hockey pitch. There's other things that need to be considered in that aim. What is the budget? Clearly that's a big one. Need to make sure that the funding that's identified for the project is actually going to be enough to deliver the dream that's in the project aim. Site constraints. Issues with site really need to be assessed to make sure that the project's viable for that particular location, and also to make sure you're aware of everything that's in relation to the site. You're trying to, a little bit like what Alistair was talking about before with using certified companies and getting venue certified, is you're trying to minimise your risk. So obviously spending a little bit more money up front, doing good things, doing good geotechnical investigation work, assessing the condition of the ground to identify pollutants, assessing what the power supply capacity is to a particular location as to whether you need to do any upgrade work, these kind of things. That's all really vital stuff. Anticipated competition standard. As Alistair mentioned, there's a range of different standards that you can get certified to. There's no point saying we're going to build an Olympic stadium if the reality is it's only ever going to host club hockey. It's about making sure, it's not to say that you don't use the same surface, but you don't necessarily need to develop the same extent of infrastructure that goes around that. So it's matching the facility and the infrastructure plan and the budget that's associated with the construction of that facility to the competition standard you expect. That doesn't mean that you don't future-proof and make sure that you've got capacity to upgrade to another standard in the future. It's about making sure that you look at where you are now, where you think you want to be, and taking the right steps to do what you need at this particular stage of the facility development. Is it pure?
Can I ask a question at that point?
Yep.
I guess what I'm beginning to see and having a look at trying to put a project together, the incremental cost of building an Olympic quality pitch is small versus a standing club pitch. Given you're spending $1.5, $2 million, $3 million, whatever the number is, the incremental cost is small.
Not necessarily, and the reason I say that is because when you build to a national standard, you've got more flexibility in the slopes that you can have on the pitch surface. So as Alistair mentioned, with the surfaces that we're using at Olympic level, once you get to a point where you're building them at grades that are outside of what's accepted for an elite facility for an Olympic standard, you find that the parameters of those surfaces change, so they'll only reach sort of a national standard certification. In simple terms, what that means is a lot of sites generally are not completely flat, and so you try and build the facility in some way to accommodate the slope and the fall and the topography of that existing site. So An Olympic facility has to be completely horizontal around the whole outer perimeter. So it doesn't matter then if you've got a really steep sloping site or a really flat one, you have to make sure that that pitch is built with a completely flat profile. So you can't utilise that natural slope that might be available on the site. That introduces extra earthworks that you've got to do. It introduces extra complications with your drainage sometimes to remove the water away from the facility. So it's not always a case of being a small incremental change. In some cases it can be quite a big difference, but it's a case-by-case basis as to how big that difference will be.
So you're saying though, if you've got an irrigator, absolutely,
Yeah. If you're going to build a field to a national standard or a global standard, the irrigation requirements and the way they're measured with the field testing is identical. So the irrigation system, there would be no difference. The surfacing price, you're right, it's negligible in the overall construction cost. The big differential is in the actual construction. Yep. So pure hockey or multisport, clearly that's a consideration that needs to come into account. Additional infrastructure requirements. It's always good that you focus on the core, which is obviously the hockey pitch facility, the pitch surface, but you then also need to consider what else has to go in with that. So obviously there's change rooms, there's club rooms, there's players' shelters, there's tech benches, there's scoreboards, there's spectator seating, there's car parking, there's all of these things, whether they are or aren't there in any form with a potential location for a new facility. Some cases they might be in some fashion, some cases they might not. So all of those things need to be considered, and again, doesn't necessarily mean they all have to be built up front, but they have to be considered within the facility development in the plan. So if, for instance, and there's plenty of cases where we've had this, where there's been a hockey pitch development that's come about sort of in a regional facility, and generally speaking it'll be where there's a hockey presence and it's a conversion of a natural grass field to a synthetic facility, and they may have limited infrastructure that's associated with that. So in the past they might have had 4 or 5 natural grass fields and people got changed in the back of their car, or they went to the game in their hockey gear and then they went home afterwards. They're not saying when we build this synthetic pitch we need to have change rooms and a clubhouse because we don't currently have it. That's step 2. What we need is we need the hockey pitch so that we can get more use and we can generate more popularity in the sport and get more participation. With that, then we're more attractive to get funding, we're also generating more revenue ourselves, and then the clubhouse, the change rooms and everything becomes the second phase. Stakeholder consultation, super critical, super critical. Need to make sure that when you're developing any project that you talk to all the stakeholders who are involved in that project, and that can be far broader than you necessarily think that it might be. So obviously you've got people like the users, the hockey players, clearly they're a stakeholder in it. Local council will be a stakeholder in it. In many cases they're the people that fund the project. Hockey clubs, hockey associations, Hockey New South Wales, the FIH is a stakeholder. The local community is a stakeholder because it's a facility that's in their community. The broader community is a stakeholder because the funding that's used for that might have been used for other things that would be used in the community or and accessed by the community. So there's a whole range of stakeholders that need to be considered. There's regulatory bodies. Obviously we need to make sure that things are built in accordance with industrial relations laws, with health and safety requirements, with environmental requirements. There's regulations, all of these things that all need to be considered. Identifying who your stakeholders are and who you need to consult with is important. And some of that can get pretty complicated. So specialist advice is really recommended to help you go through that process. Stakeholder consultation, as I mentioned, it will ultimately require resolving conflicting interests. Not all stakeholders will be exactly wanting the same thing. Some people might be, some hockey players probably, for instance, will be pushing for an Olympic surface. They'll want the best wet field surface they can play on. The association or the club who's funding it and will be managing it might say, well, you know what, we don't necessarily think that's the right way for us to go. We think a sand dress system's more appropriate. So that's an obvious example where you have a conflict in many cases with hockey facility development, is measuring the needs of the players, or the wants of the players, compared to what the requirements are from a venue management perspective, and ensuring that the cost that you put into that and the return on your investment is as good as it can be. Through that whole process, you're going to need to develop a project plan, and that project plan is your guide to then step forward into the construction process. So in really simple terms, what I'm going to do now is I'm going to give you an illustrated summary of what's involved in a hockey facility construction, just using some simple graphic designs. Step one, so we're talking about site selection and assessment. This green patch of land with a couple of trees, we're going to treat that as our site. So the first thing we need to do is we're going, okay, that's where we think we'll build a hockey facility. Let's work out some things about that site and what that means for us. So we identify the potential site location. We need to assess the suitability of that site for our proposed development. That includes things like assessing the ground conditions, so doing things like a geotechnical investigation, and also things like environmental assessment of the soil materials that are present. One of the unfortunate things in sports facility development is we tend to get at times some of the land that's commercially not suitable for other development, which means landfills, or it might be land that's subject to inundation with water and flooding and things like that. It can be marginal land, so which means that there's complications that come into the project that have to be considered from the outset. Topography of the site, as I mentioned in the discussion previously about national versus elite level certification. Obviously, if there's slope on the site and you're building a regional facility to, say, a national standard, or it's a multi-sport facility, you try and utilise that topography to your advantage as much as possible to minimise your drainage construction costs. You need to identify what the planning and development requirements will be. And as I mentioned, we need to look at the environmental considerations. So we've done all that, we've got that information, now we take that into the design phase and work out what that's going to mean for us in terms of what we actually design and construct on the site. So we assess that site topography, see how it can work for us, see how we can minimise our construction costs in terms of bulk earthworks. Assess the site subgrade. Really important that we understand what the conditions are on site, and the pavement needs to be designed accordingly. We don't have a one-size-fits-all approach with pavement design. It needs to be designed to suit the site. We need to work out pitch orientation, profile, design layout, and these are all key considerations. Obviously, all sports, hockey's no different, try and make sure the pitches are designed north-south. There's a little bit of margin for error either side of that. Sort of 5 degrees is our preference either side of true north, but you want the field to run north-south. Last thing anybody wants is a goalkeeper to have the unfortunate situation playing in the afternoon and standing at the eastern end of the field with the sun in his face trying to stop goals coming in with a hockey ball, which is obviously dangerous and life-threatening. Try and make sure whenever possible that they're north-south. That's not to say that there's not venues that have been constructed where it's not the case, but yeah, the preference is always to make sure it is. So once that design's done, we then do set-out survey work on site to enable construction to begin as per the design. So we come on site and we start our site preparation works. First things we do, demolish existing infrastructure that's to go. Remove vegetation and stripping of the topsoil, the organic material that's on site. Now bulk earthworks, which is the shaping of the remaining subgrade to suit the pitch profile. That surplus spoil that comes away, if you can avoid taking it off site and having to dispose of it, that's great. And one of the good things that you can do with hockey facilities is regularly we then incorporate that on site to build viewing mounds. So you get a double effect out of that. You save costs and you're also building an area where spectators can stand and watch the game. Next phase is to install underground services, so our utilities, electrical, water, communications, etc. I mentioned briefly before, A common pitfall with sports facility construction is not having an adequate enough understanding of the existing supply capacity that comes in, and the two big ones are electrical and making sure that you've got enough power there that if you're going to put in a 500 lux light system that you can actually power that up and that you don't need to put in an upgrade. Upgrades are very expensive. And the other one is the water, because your water supply, if it's a field that's going to be irrigated, then dictates the rate of your flow onto that site, then dictates the amount of storage volume that you need to store on site. And that's, if you've got a very, very small, very low volume feed, then obviously you're going to need a lot more storage tanks to cope with the amount of irrigation you think you may need over a weekend than perhaps you would on a facility that had a higher volume feed.
What's the normal storage capacity for water?
We normally put, depends, but normally we're putting somewhere between 40 and 100,000 litres of storage in. And again, some of that becomes a future-proofing thing. So you would never need 100,000 litres. We'd be surprised if we're watering a hockey pitch that often that you needed 100,000 litres for a single pitch. But if you're putting the infrastructure in and you're planning to build a second pitch down the line, don't just put one small tank in. That's not that's an area where it's not a big cost to go up. Maybe put that bigger tank in and start future-proofing.
Rather than the case, we've got a 220,000 build out.
Yep. Yep.
170,000 100 tank.
Yep.
You don't do anything, that's all the water from 2 fields plus the car.
Yep. Yeah.
Plenty of water.
Yep. That is. And then we start putting the irrigation infrastructure in if it's required. Stormwater drainage. We don't, with other sports fields, we tend to have subsoil drainage that runs under the field surface. That's never done with hockey. Hockey, the water runs off to the side and then it's caught in the system and taken away. Obvious reason for that is we're irrigating the pitch surfaces at the elite level for play. So we don't then want to put drainage systems immediately under that pitch surface that suck it out and take it down into a pipe network and it disappears from there. So we have a main collection pipe system that goes around the perimeter of the field, and that gets connected to a stormwater discharge point. Normally we're talking about connection into an underground stormwater network that'll be around the site. Sometimes it's a discharge into a watercourse, into an open channel, something like that. Installation of water harvesting infrastructure if it's included in the project. It's something we're starting to see come into projects more and more. Not necessarily for that water to then be collected and put immediately back onto the pitch surface, but it might be used for other purposes. It might then be used for flushing toilets, or it might be used for watering garden beds, or it might be used if it's part of a bigger sports facility to supplement the water that's used on the natural grass fields. We then start to move into the pavement construction. Aggregate pavement or crushed rock. So engineered pavement typically constructed from crushed rock aggregates. We also use recycled concrete equivalents. As I mentioned before, the pavement composition and the thickness is based on the findings from the geotechnical investigation for the site. Hockey's a sport where we're really pedantic about the finish levels and the planarity on the surface, the tolerances that are required to get certification at all standards are quite strict, and obviously they need to be because it's a ball stick surface sport, and so the way the ball interacts with the surface is important. We need to make sure that it's true and it's got regularity in that surface. So we use laser guidance control on the earth moving equipment to ensure you get high precision in the levels and in the planarity. We then tend to move on to the concrete surfaces construction. There's a range of things included in that. There's the edge detail to the pitch surrounds, so that's like a curb and channel or a drainage channel or a spoon drain or something. Normally with hockey it's a barrier curb with a channel in that. The reason we have a barrier curb is it helps to keep the ball, protects the fence basically. It gives something for the ball to hit and then bounce back in rather than hitting the bottom of a steel fence. Concrete footpaths to the pitch surrounds, really important because they limit contamination of the pitch surface. Wherever possible, we want to try and avoid people walking from a natural grass surface onto a synthetic grass surface because they'll carry contamination in their footwear and that'll contaminate the surface there and cause problems such as algal growth. Often we'll have things like recesses for sports equipment such as goal storage, and slab construction for team shelters and other infrastructure as required. We then put the final pavement layer down onto the field of play, asphalt pavement, and it's a critical element for pavement longevity. So it enables improvement of the levels and the planarity from pavement construction. Once you've got that crushed rock surface down, the asphalt layer, then you get finer control again, and more precise control on your levels and your regularity of the field surface. Every layer that we put down is about trying to improve the planarity of the pitch surface. You start at the bottom with the works that you do, and you make it tighter and tighter and tighter with every layer that goes in above it. Asphalt, one of the key reasons that asphalt's used in hockey and one of the vital components it provides is long-term value for money. It's more cost up front to put that into than perhaps not use it, and there's some cases where hockey pitches are constructed and for budget reasons it's not included. But when you're considering a project facility from the outset and you're establishing the budget, it should always be considered as a vital component. And the reason for that is the shock pad layer that goes down under the synthetic grass surface will bond to the asphalt. When the synthetic grass is worn out and we remove that, we simply do some minor rectification work on that shock pad and we reuse it at least once. We're probably getting to the situation where there may be some fields where potentially it could be used a second time. Irrigation if it's required. Those little black dots around the outside. Normally, as I said before, during Alistair's presentation, we're going with a system with 6 pop-up cannons around the field perimeter. Global category hockey surfaces must be irrigated for play. National and multi-sport pitches do not require irrigation, but sometimes it's included to cater for high standard competition only. It's a good thing to include if you've got that capability and you've got that in your budget, to be able to irrigate for your, I suppose, your top tier teams, or if you host a tournament or something like that, that you could irrigate as part of that. But you then don't need to irrigate the pitch surface every time that you're using it during the week. Significantly reduce your water requirements. Excuse me. Safety fencing, critical aspect of construction for hockey facilities. Hockey balls are hard, hockey balls travel fast, hockey balls are dangerous. So need spectator fencing to the pitch perimeter to regulate access to the pitch surface. That's normally 1 to 1.2 metres high, but we need to have higher fencing behind the goal areas, and that's normally 4.5 to 6 metres high. Normally we construct that on a 30 metre width, so it's almost as wide as the goal circle. And you should look to include retractable netting for cross-pitch training or multi-sport use. Doesn't necessarily need to be retractable netting, but it's about trying to make sure when you build a hockey facility, you want to try and distribute the use across it as much as possible, which means not conducting all of your training in the goal circles, because if you do that, the goal circles will wear out much faster than the rest of the surface, because that's where all your use is training, and that's where all of your use is focused during a match. So we'll tend to try and put practice circles in that are centred on the quarter lines, and then you train cross-pitch. If you're doing that, you need to make sure that you've got safety fencing behind those areas as well, just to protect spectators or people who are at the venue so that they don't get injured. Now we're ready to move into the surfacing. So the first layer to go down is the shock pad layer. It goes under the synthetic grass, so it's a shock absorbing underlay underneath the synthetic turf system. It's a mixture, it's paved in situ, and it's a mixture of granulated recycled truck tyres and polyurethane binder. Paved in situ for further improvements of level and planarity. Similar process to the way asphalt's done, but with specialist sports surfacing pavers. And again, as we talk about, we're tightening the tolerance. We're getting better and better as we go up through the layers and a more regular and even surface. Recycled tyres, about 85% of it by mass is recycled. It's reusable at the end of the first surface life. Completed pad. Synthetic grass surface. Manufactured and installed in accordance with a project-specific roll layout plan. Seam locations are carefully positioned to avoid the highest stress areas. We position the rolls with the seam so that there's not a seam at the top of the goal circle. There's not a seam on the goal line. We're moving the seams away from where you've got the most stress. Long straight lines are tufted into the surface during manufacturing. Circles and dash markings are cut in on site. And markings for cross-pitch training and junior pitches, as I said, junior matches, and markings for other sports if it's a multi-sport facility. We've just installed a hockey lacrosse facility, for instance, down in Melbourne. Equipment and amenities. On-pitch sports equipment and off-pitch amenities. Goals, corner flags, they should be freestanding for hockey, never stick sockets in a hockey pitch. Technical officials bench, players shelters, scoreboard, club rooms, change rooms, spectator seating, etc. Pitch lighting, nighttime training, nighttime competition, multiple switchings recommended for different lux levels, training and competition as well as for half-pitch use. And the flood lighting should be designed and the venue should be designed so that you access those lights from outside the field of play. Nobody wants to invest all this money in a synthetic surface that's compressible and then drive a 20-tonne crane on it so that they can change a light bulb. You want to try and make sure that you can do that stuff from outside the field of play whenever possible. Commissioning and certification, the final phase. Field testing and certification to FIH standards so that we get that piece of paper that verifies the quality assurance with the facility. Commission the irrigation system, aiming at the floodlights and lux level testing. Maintenance training of designated ground staff so they know how to look after the field. And we have a fully operational hockey facility. So that's an illustrated summary in pretty basic terms of what's involved. Now I'll give you a real world example. Rio 2016 hockey venues. So just quickly an overview of the Olympic Games for Rio. Starts on the 5th of August, goes to the 21st of August. It's the first Olympic Games in South America. During 17 days of competition, 306 medal events, 2 that we are obviously really interested in the hockey, men's and women's. And there's less than 50 days to go. Interestingly, in the Olympic calendar, hockey's a unique sport. As far as I know, it's the only team sport where there's been a medal winner from every continent that participates. Thank you, Argentina. So, overview of the venues. So there's 4 main sports hubs in Rio for the Olympic Games. The main one is Barra, which is number 15, that's where the Olympic Village is, that's where the athletics centre and the swimming and everything is. Copacabana's got the beach volleyball on the beach, that'll be an iconic venue for the games, for the Olympic program. I think they've got triathlon and road cycling, which is how they've got their 4. Maracana has football and a few other things. Diodoro, Northwest Hub, that's where the hockey's located. So there's 9 sports that are out there. There's an athletics centre which is used for the modern pentathlon. There's the hockey stadium, there's equestrian, rugby sevens, there's shooting, there's basketball, and mountain biking, BMX, whitewater slalom. So Polytan scope of works for this project was the development of the surfacing look. By that we mean the look of the games. The look of the games is the marketing department attached with the Olympic delivery, and it's about coming up with a unique colour combination that best ties in with the look intent for the Olympic Games. We used blue and pink in London, blue pitch and pink surrounds, because it matched the marketing colours that we used for the 2012 Olympic Games. That's why pink was used. It matched their branding. 2 different venues. Olympics always have a competition venue and they always have a training venue. So we're responsible for the field of play design, construction supervision. It was recognised early on by the FIH and fortunately by Rio 2016. Hockey is very much a minority sport in Brazil. They don't have a lot of understanding of the sport, they don't have a lot of experience with the sport, so they didn't have the design capability and they didn't necessarily understand the construction requirements for an elite hockey facility and an Olympic Games standard. So we were engaged to provide those 2 key components, field of play design and to supervise the construction works that were done by a local civil contractor. And the synthetic surfacing work. So Polygrass Platinum Cool Plus is a synthetic surface that we've developed for the Rio Olympic Games. As Alistair mentioned, it's a new system that we've developed. One of the key things that we look to do with this surface is not necessarily make it so that the playing surface was faster. We've tried to make it so that some of the feedback we've had from elite players is that how quickly an elevated ball stops bouncing is really important to them, and that's one of the things that they use as a gauge as to how good a surface is. It's how quickly the ball deadens out into a true running ball on the pitch surface, and that's something that we've focused a lot of emphasis on. And with that, in part, that generates a quick surface. So I'll just go through some photos and show you what the venue looked like. This is October 2014, first time I went there, and that's what it looked like. A jungle. They did actually have 2 existing hockey pitches there. It had hosted the Pan American Hockey Tournament in 2007. It was the only hockey venue in Rio. I think it was the only hockey venue in Brazil. That photo there, I'm not sure how well that comes up. That is an old sand-filled hockey pitch that has trees growing through the fence. I've never seen a sports facility that's so dilapidated. Hopefully that's not a foreboding of what will happen in Rio 4 or 5 years from now after the Olympics. I'd like to think that there's going to be a lasting legacy. When I turned up to that first site meeting, the people that were working on site were carrying chainsaws. That was the first phase of construction. So it was a pretty daunting project to then look at and say, well, that's October 2014, we've got less than 2 years to the Games. We've got to get cracking and make sure that they can do a good job. March 2015, during this process we were working back and forth on the design, finalising the field of play design, but the key thing that we had to do was we had to get that site cleared and develop that footprint. So they had an architect that was responsible for the overall venue, and we provided the specialist field of play design that sat within that footprint. So the works that were happening here were the enabling works for the overall complete venue development. June 2015, we finally moved into the construction proper of the pavement bases for the fields and installation of the drainage and getting ready for the surfacing works to happen later that year. So to consider that we got to that stage from a jungle in October of the year prior in, what are we talking, 9 months, was a pretty good achievement. October 2015, we started the synthetic surfacing works. Shock pad surfacing going in. I should have mentioned actually with the competition venue, in total there's 2.5 pitches. That sounds odd, but there's 2 full-size competition pitches, and because the competition in Rio is going to be run on 2 pitches, the athletes need at that venue a warm-up and a cool-down space. They don't need a complete pitch to do that on. A half pitch is an adequate size, and so we've got a half-size facility there where each of the athletes will do their warm-up and their cool-down pre- and post-match. So yeah, E-layer shock pad installation process commenced October 2015.
So when you warm up, the 2 teams that are playing are warming up on a half pitch area.
Correct. Yep. But they get allocated times, so they're not both warming up on the pitch at the same. Oh, actually, they will be, because the way we've done it is that we've got a centre line. And then we've got goal circles at either end. So it can be used like that, but generally what they try and do is they allocate times for the teams and they say you can have this 45 minutes, you can have this 45 minutes, and then maybe they both get a 15-20 minute time just before the game starts. Yeah.
What's the runoff on the sides of the ends of the
We had to get a dispensation from the FIH there. It's a really tight site, so we've only got 4 metre runoff on the pitch surrounds there, all the way around. Yeah, normally we're 4 metres on the sides and 5 behind the goals. In this particular case, we had to go back to only 4 metres, which we prefer not to do, obviously, at the elite level. But yeah, just because of the site constraints, it was unavoidable.
If you were building a new field from hockey,
We'd always say 4 and 5. Yeah, we'd always recommend that. Yeah.
I think it's 2 and 4.
Yeah.
Which is common in Europe, what's done is I would do it better anyway, which is you've got the space, it gives you a safer environment. Particularly if you have any sort of media films on the side of cords, they can't work.
One of the things that larger runoffs help to support as well is that, and it's it's an issue, it's a duality issue that comes in with the fencing. You need to build fencing around a hockey facility that's robust and is going to withstand hockey ball impact. But by the same token, if you have a shot at goal and you miss, and it hits a concrete block wall or something behind the goal and bounces back into play, then that's a major issue at an Olympic level, because there's ball kids there that'll be throwing a ball back and play could start straight away. If another ball's gone out on the field of play, you've got to stop. Everyone stops, you get rid of that ball off the surface. So we try and, the larger the runoff, the better you can try and control that. And those things do still apply to an extent at a club level as well. You don't want balls sort of ricocheting off a fence and coming way back into the middle of the field.
It's a huge problem we've got on the Central Coast. We've got a water turf here, and they're all putting waste straight next to our sports club.
Mm-hmm.
Water's got plenty of runoff on each side, 3 and 4 metres, 4 metres. But our Stanfield, which is 18 years old, on the side's only got 1.8.
Yeah.
And behind it's about 3.5. So the question we've got to take, we're just going to put the surface up, put a new shot pad down like that, or do we go big up all the way around, which makes new fences, new footpaths?
It's a challenge with older fields, and it's really common for fields to have that kind of size, and the reason it was done that way was it was about minimising the amount of wastage in the synthetic grass and trying to reduce the cost. So the grass is typically tufted at 12-foot width, so 3.66 metres, so you end up with the sidelines being a roll split in half, so you get 1.8 metre runoffs on the sides and a full roll behind the goals, so that's why you get the 3.5, 3.6 behind the goals. That's the historical reason as to why they were built that way. It's not necessarily always practical to upgrade it and extend the construction out and change it from there on. If you've got the space and you're prepared to do it, it's a good idea to do it, but there's plenty of fields that get upgraded where that's not done. Yeah.
Is this first going to be our main field? It's watching the King Lane, whereas now everyone comes up to the water field, which is a long way from the King Lane. No one goes out there anymore.
Yeah.
So our standard replacement's going to be our main turf.
Then you should be looking to try and invest in the. If it's going to become your main field, I would definitely recommend investing in the widening of the facility. Yeah.
Here's my last question. Seeing how wide the field just on one side, and the shot has got to be replaced, is that a problem, like changing the form and all that?
Well, what you'll end up, if you only widen on one side, and if you've got, say, like a central ridge line in the field, it's no longer going to be in the centre of the field. That's the only thing that you need to take into account.
So there needs to be a shot pad.
Yeah, but the underlying construction will still be with that. Yeah, so to redo that, to only widen on one side, if you wanted to have that ridge line central in the field, your rectification costs to the base would be extensive because you'd have to regrade that whole base to then reposition it. You're better off doing a little bit both sides, or you have to be prepared to accept that your ridge line is going to be slightly off centre. I know of fields where that's the case. Yeah. So moving on, November 2015, we handed over the venue, finished just in time because November 24th to 28th last year was the test event and the official opening. So every Olympic Games venue, I say that, in theory every Olympic Games venue has a test event that's hosted at it prior to the Games, where you just invite a small number of teams. This time the test event for the hockey was a South American Olympics, basically a mini Olympics. It was for the teams that were from South America that hadn't qualified for the Olympic Games, plus the Brazilian men who did actually qualify. So it gave them an opportunity to place more matches together. They need all the help they can get and the more practice they can, because obviously there's a concern they might get a few heavy losses during the Games, but hopefully not. So test event was 24th to 28th last year, official opening, and was a big success. Pitch surfaces played really well, and we identified a few issues which I'll explained some information about which needed to be addressed, which, because hockey was a sport that they don't play, and with a lot of, they don't play that commonly over in Brazil, some of the things we tried to explain to them that we were concerned about with the construction, they didn't understand. So it wasn't until we went through the test event that it made sense to them that what we were talking about, and it became the trigger for change. Certification, there they are. Both fields certified and the warm-up area. Alistair, as far as I know, this is the only non-competition pitch that's actually got global certification. The warm-up area is, yeah. Yeah. A select group of two that aren't full-size pitches but are actually globally certified. Training venue, located at Federal University, different location. 2 full-size training pitches, games time training venue for the athletes for their non-competition days. It's going to be interesting to see how much utilisation this gets this year. It'll get a lot of utilisation pre-tournament. In the past, the Olympics has been structured so that there was Men's Day, Women's Day, Men's Day, Women's Day. So on every second day, the teams would be training. It's different this year, and it's a lot more condensed because there's quarterfinals that have been incorporated into the program. So it's going to make for the hockey to be a lot more exciting, but it also means the teams play more regularly. So they won't necessarily be using the training venue as much mid-games as they have in the past. But as I said, pre-games it'll be heavily utilised. Those pitches, when in the Olympics, it's a mandatory requirement that those pitches are constructed with exactly the same surface and exactly the same design profile as the competition venue. You want to make sure that the way that people train is the way that they're going to be playing in competition. So October 2014, a game first went there. Big, open, natural grass field. Old landfill, actually. Back to the landfills again. Even at the Olympics we have to build on landfills. So that brought challenges in itself, which meant quite a lot of pavement, regular subgrade preparation work.
Can you give me an indication as to sort of incremental cost that might go into the civil preparation on an old landfill?
Not necessarily an incremental cost, but let's say, for instance, on a good base, we would normally say for a hockey field, absolute best base would probably be something like 200 millimetres of crushed rock and a 30 mil asphalt layer. We've done projects where that can easily be half a metre. Or you've got a lot of extensive remediation work that you're doing to the ground, the subgrade where you may be introducing other engineering improvement measures like stabilisation or reinforced grids or differential impact rolling to generate consolidation in the materials and things like that. So it's hard to put an actual number on it, but it's reasonable to say that you could probably at least double your aggregate pavement costs. So we're talking $100,000, $300,000 range maybe. Hopefully no more than that, but you never know. That should be October 2015 actually, and November 2015. We didn't work that fast. We didn't go from a green site to that in the space of a day and a month. It was actually 12 months. It took us a long while to get things moving on this project, but once it did get started, it went pretty quickly. February last year, started doing asphalt work. A few challenges on this project. Timing was an issue. Carnival, everything shut down for 3 weeks. We're trying to get things finished for the Olympics, make sure it's all ready. And Carnival comes and no one's around. But we got the asphalt down in February. Let that cure. Started surfacing works with the shock pads in March. Grass installation in April. And the fields were completed by early May. Final inspection sign off in May this year. And that's the facility, completed facility. So it's got two synthetic pitches side by side. There's actually a natural grass rugby sevens training field that's up in the background there. That was all part of the contract as well for this venue, for the civil contractor who built it. Again, our responsibility, field of play design and project management, quality assurance basically for the construction works. And then the surfacing. What's that, sorry?
There's no lights in between the fields.
Yep, there is. There's a common tower. There's a tower there. There's the three of them, yeah, and they're back-to-back lights. So yeah, that's those ones that are in that bottom photo that you can see there. They've got back-to-back lights on them.
What's the space between the two fields?
The space between those two fields, probably about 8 metres maybe. Yeah. Also certified. We've now got 5 certified pitches in Brazil, which, as Alistair was telling me last week, is 5 more than the FIH have in Germany. Which is hard to believe, given that they're the reigning men's Olympic champion. But yeah, we're certainly proud of the fact that we've got so many fields certified there. Shows that the construction work eventually was done to the necessary standard. But I could stand here and say, look, there's the certificates, it's all done, everything's plain sailing, but it's not actually the case. There was a lot of challenges that we had to overcome. First and foremost, the lack of local experience. Obviously a massive barrier, and language barrier. They speak Portuguese, they don't speak English. Some of the people I dealt with over there spoke English, but most of them didn't. Here's some photos. There's a photo of one of our first design meetings with a civil contractor, venue architect, Rio organising committee team, about 15 to 20 people in that room. I was the only one who spoke English as a first language. There was about 4 other people that spoke English as a second language, and everyone else only spoke Portuguese. And they don't understand how to build hockey fields. So trying to communicate that to people and get them to understand what's involved from our side was a real challenge. But fortunately, drawings have the same universal language, so everything was done with hand sketches and things like that to help them try and understand what was involved. And then I realised I better learn some Portuguese as well. Multiple stakeholders. It's not just an issue on club level fields, it's an issue at Olympics as well. It's almost more of an issue at Olympics because there's so many other stakeholders. We're talking about things like making sure that each of the teams are going to have the facilities that they need, obviously, that there's drug testing facilities, that the Olympic Broadcast Service has the facilities that they want, that the pitch colours are what they want for broadcast purposes. All of these things, the FIH have clearly a vested stake in it and making sure that this is delivered properly. It's a whole range of stakeholders. And we're dealing with civil contractors that have never built hockey pitches before and don't understand what we're talking about. Those design team meetings were worse in the actual construction meetings. More people on site, more people involved, more people having an input, more people who didn't understand what was involved. So it's hard to resolve project issues on site when you've got large groups of people there. So the lesson learnt from that was limit the site meetings to core project team only for the greatest effect. So instead of trying to talk to 15 people standing in a circle next to a car, you limit that to 4 or 5 people, and you pick the people that are the decision makers relevant to the issues that are at hand, and you deal with those, and then that gets filtered down and communicated back from there through to the other stakeholders. Some of the other project challenges we had are things like this: materials handling. Our synthetic surface installing team almost cried when they turned up on site and saw the way the grass had been unloaded and stacked on site, which was outside of our control. Unfortunately, pieces of wood sitting on top of rolls of synthetic grass with other rolls of synthetic grass put on top of those, creases in the rolls, tears in the rolls. Yeah, we wouldn't want that on any facility, let alone an Olympics pitch, which is under high definition TV broadcast. It's pretty hard to make that look good on TV when you've got that damage, but the guys did a fantastic job. Restricting access to work area. It's a big venue, there's multiple trades on site. We couldn't close off our workspace all the time, and we had huge problems with people walking across our surfaces when they'd just been installed and weren't cured. Footprints in shock pad layers. We had, I think the record for one area was we had to repatch the one spot 4 times because people kept walking in it. We'd remove it, we'd patch it, they'd walk in it, we'd remove it, they'd patch it, they'd walk in it. you're working to really tight time frames to try and get things finished, and you're having to repeat your work because of things like that. It's really frustrating. There was also an issue once the synthetic grass got installed. They put down, just prior to the test event, they put some primer asphalt seal onto the broader surface areas around the venues, and we had all sorts of problems with people walking from there, shortest route, going straight across the synthetic grass, walking off uncured bitumen onto bright green synthetic grass and leaving brown footprints of asphalt and bitumen behind on the pitch surface, which is pretty heartbreaking and added more time on at the end of the job in trying to remove all those marks. But the bigger challenges are the things that they didn't understand, and they had to see firsthand how big an issue it was for us before they could understand it. And things like the fencing, and identified early on that the fencing design was not part of our scope. Our scope went up to the fence line, and it was decided the fence was the perimeter, the boundary between architectural overlay and field of play design. We gave advice on that at the time of the design and expressed some concerns. It was constructed. We expressed some significant concerns thereafter, and there was big issues in the test event which caused some problems with fence panels falling out. As you can see there's a panel that's just fallen completely out of the fence. Panels getting bashed and dented by hockey balls, coming loose. And as a temporary measure, they ended up having to remove some of those panels and just put netting on and tie it to the fence. There's rectification work that's now happening to improve that and bring that up to what we would consider an elite competition standard. And attention to detail when you're working in some of these developing countries or places where they don't understand the sport can't be taken for granted. So that there is a classic example. That's the high fencing behind the goals for spectator safety, which finishes 150 mil off the ground, and a hockey ball 76 mil in diameter. So a hockey ball goes over the field, hits that fence, runs down, and that all slopes back away from the field. So the hockey ball ends up running out from under there, under the temporary stands that are being constructed behind it. So they need to now fill something in under that space to stop the hockey balls getting outside of the field of play area. And things like just finishing off manholes and inspection covers and things like that was not done well. There's one that broke and wasn't installed properly. There's one that wasn't installed at all. Here's one that was covered in concrete. Here's one that's finished where one sits flush in the concrete, the other one sits 40 mil proud of the asphalt. And here's a slotted drainage channel that's been installed around the outer field that somehow they've pushed wide, they've widened it when they've installed it, and now the channel covers don't fit in it. Just little attention to detail issues that have needed now to have rectification work done. But as they say over there in Brazil, it'll be all right on the night. So the Olympic Games, 5th to the 21st of August, we're almost there. We're almost finished. Myself, Alistair and some of his colleagues at the FIH, we've still got a few restless nights ahead of us as we resolve some of the final issues. But as per the test event photos, we're going to see a pretty impressive hockey tournament that's over there. What I should have said actually with the colour combination is, so it's a blue pitch, it's the same shade of blue or very similar to the same shade of blue for the field of play that we used in London. We've developed a unique shade of green, Rio green, we're really original with our names, for the pitch runoffs, which matches in again with the look of the games and the colours that they're using for their branding.
Is there a specification on the colours?
We matched a Pantone for that colour, yep. It's a really difficult process. It took us about 6 months, iterations back and forth with them to do that, which is a pretty expensive process. You wouldn't do it for every single job, but you do it for the Olympic Games because it's such a high profile event. The white lines, so the blue and the green in combination with the white game lines and a yellow ball represent the 4 colours of the Brazilian national flag. So that's the overall design context for it. They're not the specific shades of colour that are used on the flag, but the 4 colours in principle represent the flag itself. And that's it for me.